you will not find any of that in any server.
The console port was removed from the production board.
Maybe this is not hardware problem, this is not physical. And then you need to theorize with the team what are the potential problems that can make this to happen.
How come no other customer was seeing the same problem?
That was interesting. We didn't. It was very specific component.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan. In today's episode, after 2 years of experiencing random crashes on many UCS servers, the solution turned out to be simple, but the troubleshooting required a soldering iron?
Hi, everyone, and welcome to the Tech Stories podcast, a podcast where we interview guests and get their most interesting troubleshooting stories. My name is Nicholas. I'm a tech lead in wireless in the EMEA tech centers in Cisco, and I'm here with Tristan.
Nico, how are you?
Pretty good.
Yeah, I'm looking forward for this next episode. It's gonna be our, what is it, 5th or 6th already?
Yeah.
Yeah. So time flies, and I'm really looking for this one because we have a great guest and a great story coming up.
Okay. What's the topic of today?
Let's introduce our guest first. So our guest today is Ricardo. He is coming from the data center world. Hello, Ricardo.
Hello. Thank you for having me.
Yeah, welcome. So, can you tell us a little bit about yourself?
Absolutely.
What's your background, where you come from, and the story that you have?
Thanks so much. So, my name is Ricardo Galvan. I'm a technical leader in the UCS space. It's the Cisco's offering for compute market. I'm Mexican, now living in Portugal. I migrated looking for expanding my knowledge and my experience to other fields. And I started my career as a field engineer. Interestingly, I was the guy who goes to the data center and, you have a problem, you replace something. And then I was learning a lot of things but my experience doesn't start there because before, when I was like 15 or 17, I worked with one friend whose parents has some business for building your own computer. I was learning about SAS cables, about HDDs, about DIMMs.
At 15.
At 15, yeah.
Very nice.
Like a lot of us actually in IT, you just built your own computer and
Build your own
started to
computer.
like it, right?
And actually, that's something that I always ask in an interview that, have you built your own computer already? And when I hear no, it's okay. You might want to look at, what is the cable that connects an HDD or something.
Are you into water cooling, RGB?
RGB? Yeah, because if you know already this, I mean, you have some progress there. And well, then after being field engineer, I worked for a Cisco partner, some like 4 years. And at the beginning, I wanted to be, security and other technologies, but someday I got the opportunity to start learning storage and compute. And I just remembered everything that I learned before, and I loved that. I was a professional service engineer. At some point, I did some pre-sales. I was also a managed services, working directly into the customer environment, managing their equipment, focusing most of the time on compute and UCS or other brands too. And then for whatever reason, I got into Google, in which I worked for 6 months. And it was pure software, but I didn't feel, I felt that I was going into a different direction. And then I saw an opportunity with Cisco to work with the technology that I worked the most, UCS, and started in TAC in Mexico. So it was in the happiest days because I was taking cases. I was back into the things that I used to do more. And now that I see the other side, the story where there's somebody troubleshooting and telling the field engineers what to do and why to do that, I just simply got in love with this job.
Cool, very nice. Interesting background, by the way. You touched a bit of everything. You've seen the both sides of the house, the management side, the technical side, the software side. Mm-hmm. Very good. Very cool. And what story do you have for us today?
Yeah, it's interesting because this story reminds me of my beginnings of the career, like being a field engineer. So we had this escalation. There was the problem with some servers that out of nowhere they were just shutting down, and when we tried to recover them, we couldn't integrate the UCS to the Fabric Interconnect. So basically, what it happens is you have two flavors of servers. You have the UCS B series servers, and then you have the UCS C series servers, which are rack, and they can work independently, like a standalone, or you can integrate them to the UCS B series Fabric Interconnect. So your management is in a single pane of glass. When we tried to do that, it was failing. It was not completing. It was going in an eternal loop, and suddenly, we had to downgrade and do some tweaking there so we can put it in the environment and work again. But then suddenly, like 2-3 months later, another shutdown, and we were having, we were going in loops without knowing what had happened. We got the business.
Sorry, was it one server shutting down or
multiple servers actually?
Randomly, like just
randomly, but it was weird because customer had like 20 servers of the same platform, but only like 6 of them were going nuts. So it was crazy. We didn't knew what was the trigger because it was they were not shutting down at the same time. They were suddenly on Saturday a server went down, and the next 2 weeks another one went down. We didn't have a clue. We got the business unit looking into it. We got developers looking into the logs, and suddenly you could see the shutdown, but no reason behind it. It was just we had a lot of theories. Like the craziest theory was that maybe a energy company near to the site could be having some energy spikes, which will create harmonics, which could shut down the PSUs and bring the system down, but we couldn't prove it. So we decided after 2 years actually to send me to the site, take a look, and the VU recorded this video.
Did you just say 2 years?
Yeah, 2 years.
So the case went on for 2 years, and
Yeah.
for 2 years they had random shutdowns.
Yeah. But it was weird because for months everything was good, like 2 months, and then we were about to close the case, and we closed it, and then customer came back and hey, we got another shutdown. Your workaround is not solving anything. We still have the same problem, and we go back to zero. It was very weird. So the VU gave this workaround. Basically, they give us a debug cable that you can connect directly into the motherboard, and they gave this video how to connect it and how to start the debugging. I traveled to Switzerland.
So what kind of debug cable? Because
it was a tweaked cable. It was nothing that you could find in a store.
So it's not like a console cable that you plug on the router. It's something that you need to plug internally on the server.
Yeah,
right?
because essentially what it happens is if you connect to the SSH port or management port, you will pass for some authentication processes in the motherboard. But this cable bypasses that and gets directly into the BMC, which is the Blade Management Controller, and allows you to go directly into the kernel. Basically jump all the security. It's meant for engineering, and we didn't knew that.
But what kind of data does it give you? Is it like just error codes, or you get actual text that you can debug? And
yeah, basically when you're booting the server, all the processes in the BIOS will be displayed, and everything that is happening.
So it's like a console, but just low level, right?
Exactly. Okay. Yeah. So. So basically, I get into the site, and at the moment I open the box, I don't see the connector or anything that it's in there, and I'm shocked. Like, okay, nothing that I was supposed to do here would be possible. I call the VU and say, hey, I don't have this thing. They are surprised as well. Like, why do we have this thing? I send them a picture. They bring a product manager, and he says, oh yeah, but that's because. That is not meant for customers. I mean, we use that just for engineering testing before we launch products. So you will not find any of that in any server.
The console port was removed from the production boards.
Because it's not meant to be used by people, right?
Yeah, no, it is not.
Of course, yeah.
So they tell me, oh, well, you gotta find out how to solve that. Then I said, okay, well, I looked into the pins. It was just regular pins, like any other pins in it was literally just like the pieces for connecting something. So I called the account manager. I tell him, hey, I need to find out some soldering gun, some soldering, something that I can work with. I can do I know how to do the job.
So you're thinking about soldering pins,
Yeah.
but where to? Like you need
Into
a
the
chip
motherboard.
or something, right? You knew where they were supposed to be, right? So you knew where to solder.
Yeah. Because I saw the diagram, and then he told me, okay, that I found just a place in Switzerland. It was in Zurich, so you can go there and buy some soldering gun and soldering paste, anything that you need. Just buy it. I go there, travel by train. It was like midday. I buy all this stuff, and they were asking, "What are you gonna solder?" And it's like a motherboard, but well, like micro pins. The guy just sell me a big con, a lot of stuff. Then I go back to the data center, and I'm saying, okay, I cannot solder inside the racks because there's the fans, throwing all the air into you. Then I take the server. I go to security. They say, no, you cannot take it because, well, it's not yours, and you don't have the clearance to get it. I called the customer, and this was an on-man site. The customer was like 3 hours away. They couldn't get the approval. Then I'm wondering, and suddenly I saw a janitor crossing by, and I asked him, "Hey, do you know where can I connect this thing because I need to do some soldering?" And he said, "Oh yeah, let's come with me." And he bring me to the cafeteria, and he said, "I mean, this is the only place where you can connect because otherwise, there's no other place to put your stuff." And I'm there in the cafeteria with people going, on and off, bringing their sandwiches or their lunches, and I'm just in the middle doing the soldering. It was a test and fail or try, because every time that I tried and like putting some pins, sometimes they were not well soldered because that thing is also done by machines. So doing normally it will require some more, I would say, technique. But anyways, I managed to get it by midnight. The VU connects and say, okay, I see now the debugging. They start to look into the code. We identify what was breaking down, and then they say, okay, I think we have a potential fix for this, but will be in a different in a future release. And then I just remember how it was when I was field engineer, replacing the cables. But now that I am technical leader, I'm glad that I had that experience because that helped me to resolve this problem. And well, after 2 years, we managed to understand it. It was basically the BIOS when it was bringing up the server. The big card is the connector from the UCS to that connects to the fabric interconnect. It's for networking and management. It was not giving the output because the flag was not changing when it was getting integrated to the UCS manager. And they do some workaround in code to force the flag to change, and that's all. Software problem.
So once you figure out how to get the right data, the fix was easy, but the part to get there was really the challenging.
Yeah. And that's because you cannot see anything from the BIOS when it is booting, because since it is connected to the fabric interconnect, well, you don't have access at all. So we did some tests in a standalone, and in standalone mode, everything was good, no problems, nothing. So that's where we started to think maybe this is not hardware problem, this is not physical. And then you need to theorize with the team what are the potential problems that can make this to happen. So software affected by hardware, but if you look from the software side, it doesn't make sense. If you look from the hardware side, it also doesn't make sense. So you need to, get two worlds.
I have multiple questions. How come no other customer was seeing the same problem?
That was interesting. We didn't. It was very specific component, and actually they were wondering as well. They asked us, "I don't believe that I'm the only customer getting affected by this." But either there is no customer doing the same configuration, or they were on a different version, or they never upgraded. We don't know. It was the only customer having this problem.
Actually, that happens a lot. Customers always think, hey, I must not be the only one, right? But sometimes, the combination of triggers is so specific that maybe there's one other customer facing it, or just no one.
Yeah.
That happens.
Yeah, they have very specific configurations, and that happens a lot. In escalations, there's customers saying, like, I don't believe that I'm the only one having this, but then you look into the all the infrastructure, all the configurations, all the applications, operating systems, all that conjunction of items, it's unique to every customer. And if you don't study that, then probably you don't have a point of comparison. Yeah, it's complicated.
I have another question, because your story reminded me of me trying to solder things on my Xbox motherboard for perfectly illegal reasons that I completely dropped afterwards. And I killed that Xbox basically, because it's very hard to solder something on a motherboard without soldering on 2 pins at the same time, because it's so small. So what would have happened if you were not as good as that in soldering? Like if they sent me on site and I would be like, no way I'm soldering something here, man. Like it's not going to happen.
That's basically, well, at least having some background working with hardware stuff. It remind me of, remember PlayStation 1?
Very well.
So I'm not sure if here it happened, but in Mexico it happened a lot, where you have these illegal discs, that are basically, you put a disc in your computer, you mount the ISO, and there you go. You got a illegal game. So what it happens back then, it was in the 90s, yeah. So the motherboard will have this authentication chip, which basically whenever you have a original CD, it will get into a section of the disk and it will look for the section of the authentication part, and the chip will look for it. So the tweak for making that solution was to put a bridge, a cable basically between BIOS pin and bypassing the authentication. So that tells you that somebody could have who have access to the schematics knew about this. Then they just tested, putting a cable, what it happens, and then if you know how to read the schematics, then you know how to follow the connections. And but that it requires you to have some experience in the field. But it is not necessary to be an engineer for doing that, because in Mexico you could go to a market, pay some 200 pesos or something, and then there will be some guy who is not even or have a career and doing these kind of things, and anyone could do it. That's something that I like, because I learned from my experience with the first job that I had, that if you have the patience to go on internet and read all the documents, I mean, you can do a lot of stuff without having.
You can learn anything.
Anything. Yeah. I think that's the beauty of the compute, that you don't need to be an expert. I mean, it helps a lot because later you understand the nuances or the caveats about hardware and make sense to troubleshoot. But at least for starting into the career, having just the love for compute, it's what gives you the patience and the willingness to continue on the same path.
So I just to close the episode, I have a question on my mind. UCS was like very cool when it came out, and now, of course, the cool always moves to another technology every 2 years, right? So that's fine. But UCS is definitely not dead, right? People still need servers. What's the future of UCS? What's the strength of UCS? Why do we need a Cisco UCS? Why? Because people talked about white boxes. Oh yeah, you just need a motherboard and some RAM and you're good to go. So
that's an interesting question, because we get that from customers a lot. I think it's the differentiator, right? Because you can go outside and buy any server. Even you can buy your own server at home. You can buy a Raspberry Pi, put some CPUs, some DIMMs, and install Linux on top, and then you got a server, right? But it's about the services, the features, and the support as well. I have this fight with the software people who they say operating systems and software applications are agnostic to the hardware, which, yes, it's true, but somebody has to support that, right? So somebody's in the back end developing new hardware, new capacity, new features, and they're putting everything together so you can have a more solid product and compete with other hardware vendors. Because at some point the hardware the compute vendors We'll also partner with other hardware vendors like Intel, like Samsung, like Broadcom, to get all these pieces together and have a solution, a compute solution that will later be sold. And most of the compute vendors, they partnered with Intel. Intel is a major vendor for CPUs, but also we got AMDs, we got Ryzen, but Ryzen I don't think they're on the DC market. But anyways, the differentiator of UCS is that basically what are we offering? Like, for example, for years we had the UCS manager as our main offering for the blade market. Everything was Linux. Getting some tweak on the NXOS so we can enable the UCS manager. It was a monolithic approach, but later now with InterSite, everything moves to the cloud. The management is in the cloud. Instead of having processes in Linux interacting with themselves, now we have microservices in the cloud that are giving you specific features or specific functionality for your servers. And everything moves now via REST API. So your management and your way of understanding the technology is different, more reliable, more secure, because now you remove certain vulnerabilities. You allow the cloud to ensure that your environment is safe and it's accessible at all times. In the past, if you had a network down situation, then you will lose access to your servers, or your servers will not be able to connect to the management. Now with the cloud, and you ensure that you have activity, or availability of your environment 24/7. Despite of having, internal network problems, you still can get into your environment if there are some paths to the servers. And I think that's the Cisco value right now. We're now launching UCSX, or UCS have been launched from M6s and M7s, and there's a lot of improvement there. There will be, Cisco is attaching to the trends of the market. Before, we relied a lot on fans to cool the servers, and now the market is moving towards a liquid cooling. So we'll see an evolution and an adaptation of the compute to what the market needs, because we have more powerful CPUs, we have DIMMs with bigger capacities, and we need to somehow run across towards what the market is requiring, and adapting ourselves to the future.
Nice. I want to jump on that one, because the whole industry is moving to energy efficient, consuming less power, etc. And you're talking about liquid cooling. I'm not sure, did the servers become more and more powerful in terms of wattage and heating, that we need to go that route?
A lot, and I have a story about it. You probably remember those Pentium CPUs like 20 years ago. Then Intel was growing those CPUs over the time, getting more megahertz, gigahertz, etc. They reached to a point where the clock was spinning too fast that it was starting to melt down the CPUs. That's where they came with the dual core CPUs and multiple core CPUs. They realized that doing parallel processing will and less power will ensure that you would do the same or even more processing.
Optimizing instructions per cycle as well, rather than just more megahertz.
Exactly. So, but they introduce a different problem, that is coherency. You resolve a physical problem, but you introduce a logical problem. So because both CPUs need to know what the other is doing, because otherwise they will do whatever they want, and you don't know what is controlling what. And technology has been evolving in that sense, like resolving the physical problems, and trying to resolve at the same time the logical problems. So right now we're in the era where the cores are getting into the I would say the limits. So we're trying to resolve now the logical problems with physical, because the CPUs with multiple cores are generating too much heat. And if you take a look into the heatsinks, comparing the old models to the new models, these are totally different monsters. These are very heavy heatsinks trying to dissipate the heat, but also you have a lot of fan power. But even when you have fan power, the technology keeps growing. I think it was like 2 weeks back where Intel showed the next generation CPUs, and the heat that those things are gonna generate, it's massive. So we need to adapt ourselves to, lower down, because heat translate to electrical issues. Even for example, for the DIMMs, they reduce the operating voltages, so they can get more speed. So you spend less time filling a capacitor to get a logical one, and that translate to performance, to speed and capacity, but also at the same time introduce physical problems. So we need to, or actually what we're doing, it's resolving all those physical problems and logical problems with whatever we can. Liquid cooling is now the topic that everyone is talking about. How is this supposed to lower those problems? And we'll see how it goes, because there are experiments everywhere. I don't know if it was Microsoft or somebody else who was testing getting servers inside this liquid special for electrical. Basically to avoid electrical problems and the effects of cooling, the servers inside some liquid. So they're
just dipping it inside a pool of liquid.
Yeah, it's there's some crazy things going around, but that's what it makes the evolution, right? The technology evolves by testing the things that we never thought might be possible.
Nice.
And I think it's a nice closing word. So
Good.
Thank you very much, Ricardo,
Thank you
for your story, your passion, and also the explanation that you just gave. It was very nice. So thank you very much.
My pleasure.
Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on Cisco Podcast Network and SoundCloud, or in your favorite podcasting app. You can also find us on X at Cisco Tech Story without S. Thanks again for listening, and speak to you next month.
Next time on Cisco Tech Stories. That was a bug that could cause anyone with zero privileges, just the ability to be on the network and send one frame of SNMP, they could take out an entire data center.